Let's get started. In the world of security and observability, we see similar problems but different solutions to solve those. We see blind spots where we miss visibility in either security or observability related issues. We also see point solutions that make it hard to correlate all information. You need context and correlation, and that's missing in both industries. The ultimate solution will be a single UI where all team members can work together on the most important issues to find them fast and fix them even before they become a real problem. In this webinar, we will show what we see are the biggest problems in the security and observability space. Let's start with the security space. Over to you, Steven.
Yeah, thanks, Mark. So yeah, as a solution architect for Prisma Cloud, we often speak with security teams and we get feedback on the challenges that they experience. And also the numbers that I share on this slide are coming from our cloud native security report, which is actually created by our colleagues from Unit 42, our intelligence unit within Palo Alto Networks, and together with the teams from Prisma Cloud. And one of the biggest problems or challenges that we have seen within organizations actually is staff shortage. It's very difficult to find the right people, the right resources in terms of security with a lot of security knowledge. So basically the ratio that we see between security engineers and developers is here 1 to 10. But from my experiences in the Netherlands, I can say that most of the times it's actually 1 to 40 or 1 to 50. And the result is that there are much more developers or DevOps people working with infrastructure as code that create alerts and issues than you have security people that can solve these issues actually. So that's one of the challenges. And if we go to the second one, that's actually blind spots. That's another challenge for organizations working with cloud and cloud native technologies. And the issue is, and I will speak about it more in a few minutes, that we see a lot of point products and there is no correlation. And if you miss out a specific gap, a specific point actually between code and cloud, then you're actually having blind spots in your environments. One other challenge that we see is if you have a multi-cloud environment, you also need to have the right tools in place to make sure you have no blind spots in one of these clouds, or actually one of the technologies that you are using. The third problem, and this is a really huge problem if you also think about the resource and the lack of resources, that's the slow response. Typically, what happens within organizations, they have cloud security tools and they bring a lot of alerts, maybe also some noise, and the security teams need to work from these alerts to find the actual business owners of a specific application. And then within the application teams, you need to find the right developer who is actually responsible for the code generating the alert. And if you found the developer needs to find the right code, fix the code, and go through the CI/CD pipeline again. This process can take up to 145 hours according to our report. And customers that I speak with confirm actually that it takes a lot of time. One of the examples was yesterday where I spoke to a customer and they could really relate to this issue that it takes too much time to go from an alert to the developer, and it also generates friction between security teams and application developer teams. Over to you, Mark.
Thank you. What we see for security teams is also something we see similar in SRE teams. Also there we see that there is a staff shortage. The ratio between site reliability engineers and developers is also 1 to 10, sorry. What we also see is that developers find it hard to get access to all observability data needed for troubleshooting because of point solutions. They might have access to the logs, they might have access to the metrics, but sometimes they don't see the traces, and in many cases they also don't see how everything is connected. And what that gives in the end as the biggest problem is that we have slow responses. It takes typically between 1 and 12 hours to have a typical critical outage being resolved. And that's because you first have to see what's going on. So you have to detect it fast enough. In most cases, that's quite okay. Not in all cases. But if it's detected, you also have to see how is everything connected. What's the source? Which change was the cause of that? Which development team is responsible for it? And in the end, change the code to make the fix or do a rollback. So it's a very similar problem. Over to you, Stephen.
Okay, thanks. Yeah, if we look at how an application is built up in the software development lifecycle and what you need to get your application built and running, then we can separate it in three parts. It's actually the code part, the infrastructure part, and when your application is running, it's actually the runtime. For example, on a Kubernetes cluster based on microservices. And we see a lot of risks actually in all of these stages. And if you look at the code, then the two biggest risks that we see are, one, open source libraries. In the past, we saw organizations actually, of course, using open source libraries to build their application, but it was mostly 20% open source libraries and 80% own code on top of that. And right now, it's actually the other way around. So 80% of applications exist of open source building blocks. And you need to know what's inside of those building blocks in terms of vulnerabilities in the full supply chain. Otherwise, you will get those vulnerabilities like Log4j actually coming into your supply chain and in your runtime environment. Other risks that we see, and especially in cloud environments, is, for example, identity. It's really difficult to calculate actually the net effective permissions and answer questions like, who has access to my database, or who is able to destroy my data. So it's really important to have a solution that can answer questions like these. And of course, in the runtime, we have traditional risks like CNC execution, malware, but also zero-day attacks, targeted attacks. And today in the demo, I hope to show you actually how Prisma Cloud is able to prevent these attacks. One other thing that we see here is that if you talk about these risks, the typical response for an organization is to solve these with point solutions. Maybe there's a specific application team using a certain technology, another application team is using another technology, and for a different risk, you see a different vendor and a different solution. And then you'll end up with separate solutions for software composition analysis, something for SaaS, cloud identity management, but also workload protection in Kubernetes and web application firewalling. So this is one of the challenges that we see, because it needs a lot of resources to maintain knowledge for these vendors, technologies, and you miss out on correlation. Over to you again, Mark.
Amazing that you see all these point solutions in the security industry. We see similar open source point solutions brought by different teams. And then the observability complexity is just growing if all those solutions are brought into place. So first of all, of course, a developer uses different source control systems. But then when it's in the cloud infrastructure, the cloud runtime, they have many tools to interact with those runtimes or with those infrastructures, and also multiple point solutions for observing different types of technologies or different applications, which makes it hard to get to the root cause of a problem and also see what's the effect of a problem and which alerts to take first, because you get so many alerts. To solve this, we need context. The problem we see is that engineering teams should be empowered to be autonomous in detecting and solving integrity and compliance issues effectively. To solve this, we need context. Stephen, can you show how in security you can bring context to the next level?
Yeah, definitely. If you think about security, it's extremely important to have the context. And this is what we've been working on with Prisma Cloud in the past few years. We got a new release of our platform a few months ago. And this is really the strength of having a platform instead of point solutions. You have more context, and the more context you have, the better you can prioritize risks, for example. So if you look about the risks, we can consolidate findings by using the attack paths. And I will explain a bit more on that in a few minutes. Basically, what we use with context and risk context is that we do not look only at specific misconfigurations or vulnerabilities, but we look at the context and then tell you how to prioritize those issues. And the second one is application context. In the past, security solutions like cloud security solutions were mainly focusing on assets like instances or workloads. And it's much more important actually to understand the application context, like is this a business critical application and who is the business owner? third context is app lifecycle context. So with, you can go to the next one, Mark. If we look at the full software development lifecycle, it's extremely important to not only look at a specific part of it. This is an example where we see actually why that is important. If you remember Log4j from 2 years ago, it was a real big challenge for organizations to understand the impacted resources. And right now, within Prisma Cloud, it takes only a few seconds to tell you actually what the impacted resources are. And we do not only do that in runtime. If you compare it 2 years ago, organizations were actually struggling with this, and it took them days or even weeks to understand the impacted resources in runtime. Prisma Cloud shows you like this visually in a few seconds where you are impacted by Log4j or the next Log4j in runtime, deploy, but also in code and build phase. Can you go to the next slide? Yeah. One other advantage of having a platform is actually that we can relate the runtime to the source. So if you work with Prisma Cloud, we can tell you if you have a misconfiguration in your cloud environment, and you are able to quickly fix it by just a few clicks, either by Prisma Cloud guiding you on how to fix your cloud environment, and then you have a quick fix on your running workloads. But actually, what makes more sense is to look at the source, like the infrastructure as code, because things like misconfigurations and vulnerabilities often have their origin in that code. And by relating actually the runtime to the source, we are now able to fix that 145 hours and bring it down into one click and make it possible actually to, with 2 clicks, generate a pull request and fix the actual issue forever in cloud, in your code, sorry. So that only takes 2 clicks, and then you see fixing code, and Prisma Cloud will actually generate the pull request to fix the issue. And another advantage is that developers and DevOps engineers do not need to go to a solution like Prisma Cloud, but Prisma Cloud actually enters their workflow by that pull request. Next one. Yeah. Attack paths, I'll try to briefly explain and show it in the demo. But one important topic is that we see when we look at the context, we also understand not only a specific misconfiguration, but we look at the system. And for example, if a system is just having a vulnerability without exposure, that's obviously of a much lower risk than having a system that is vulnerable and exposed to the internet. And this is the effect of having attack path alerts. This is feedback from our customers, where we went actually from roughly 5,000 alerts to only 53 critical issues, and the security engineers had a much more improved way of their daily business and going through the alerts, and they knew much better where to focus on.
Thank you.
Over to you again. Yeah.
In observability, we see similar problems. We have many personas and many alerts. And also here we need to bring context between those tools, but also between tools and industries. The business owner should be in control and run his application with confidence, always available with confidence in the integrity and confidentiality of his data. There we see there is a need for a single easy-to-use interface for integrity and observability for efficient and independent troubleshooting for autonomous engineering teams. What I mean with that is that as a business owner, you own a set of applications. Those applications are mission critical and they form different chains. And in the end, you have network operation centers and CISO overlooking those different chains, which in the end are different applications where you have application owners, which also need to see parts of the data, but not all. And then in the end, it comes all down to the development teams and the platform teams to run the different clusters and the infrastructure and to run the applications on top of them. And all of them are in the need of having contextual information in a single tool to effectively troubleshoot. And what we see there is that it's hard to get access to all different types of telemetry data. We see that some teams might have access. Some teams might have access to the logs and events. Some might have access to the traces. But in many cases, that's not in a single tool. And they use a lot of tools, switch between context, and that really slows down troubleshooting. For instance, yesterday I saw someone diving into the system. There was a critical alert, and then he was looking into Alert Manager. From there, he looked into Grafana, saw the graph, but he had no clue of how that alert was related to other alerts which there were also coming in. And in the end, you just do not want to get lots of alerts. You want to have that context, similar like Stephen just shared. You just want to see how is everything impacted, what's the cause of it, and what are all the signals related, and at which time was it. What you then also see that if we get to the point that the right person looks at the right alert, you also still need to have the knowledge of what to do. So for instance, if you get an OOM killed or image pooled issue, or there are insufficient resource allocations, you must know what to do there. And basically, in context, you want to have instructions on how to resolve the issue, and not only an explanation of what's going on. Then, what StackState does, it brings all data in context to the role which needs it at the moment they need it. All the time, at the moment you need it, within the context where it's needed. And we will show you more in the product demo. Over to you, Stephen, for the first part of that.
Okay, awesome. Thanks, Mark. I try to share my screen. Just give me a few seconds. Into main screen. I think this is the right one. Yeah. So this is the dashboard that we just saw in the slide deck. And I think Mark, can you confirm that you see my screen?
I can confirm I can see your screen. Yes.
Okay, great. Thanks. So yeah, what I will do in the next few minutes, I'll show you a very high-level overview of Prisma Cloud and how we can secure from code to cloud. I will wrap up with a runtime demo on how we can actually protect your container environments against zero-day attacks. So if we do not know actually how we are going to be attacked, how is Prisma able to protect those attacks? And then after that, I will hand over to Ravan to show StackState and the integration with Prisma Cloud. So to start with, from the dashboard, this is what you see if you enable Prisma Cloud and you onboard your cloud accounts, your runtime environments, your registries, and also your repositories. Then we can actually relate and tell your organization how you are doing in trends in terms of issues in repositories, but also we scan images and also in runtime. And basically the aim for Prisma Cloud is to decrease the number of incidents and vulnerabilities in runtime, because we want to focus on prevention first. And I'll show you that in a few minutes. So what we see here is actually one of the attack path alerts where we bring all the context together. And what we see here in the middle, actually in the center of the graph, is an instance that is generating this attack path alerts. And we could tell you each single misconfiguration or each vulnerability as a specific alert, but that would mean a lot of work for your security resources. So what Prisma Cloud does actually is look at the context and only show those attack path alerts that should be prioritized. And in this case, we saw a SQL and code injection attempts on an application at the endpoint that has S3 access. It's misconfigured, it's exposed, and it has critical vulnerabilities. And what we see here in the graph is actually the evidence. So this is for a much better understanding for a single pane of glass. And we see actually on the left side the full path that leads to this specific asset. So this is for understanding, and on its own, this is not an issue. Because if you create a web application or an API, you want your consumers to be able to reach that application or API. So that's not an issue. But if you consider the same asset also has critical vulnerabilities, then that's a really different story. Because now I have something attached to the internet that is really vulnerable. And additionally, I also see a misconfiguration here. And this combination is actually the same combination that we saw a few years ago within Capital One. And for Capital One, that led actually to a breach and a fine of $190 million. So that was really huge. And now we see actually the same things that can go wrong. Additionally, as mentioned, Prisma Cloud also focuses on identity and access management in cloud. So we can also tell you, if you look at a specific user or role, how much permissions they have. In this case, we see that this asset, this instance, is part of a node group, and it actually has permissions to access my S3 bucket. Now, let's have a look inside of that S3 bucket, and we'll see from the same single pane of glass that we actually have quite some important data in there. We scan the data, and we can tell that this is actually PII data with healthcare information. So now I am really getting worried because I have an asset attached to the internet. It's exposed, it's vulnerable and misconfigured. And if an attacker gains access to this instance, they immediately have access to my private data. So that would be a huge breach. So what we see here is actually Prisma Cloud showing what can go wrong. Additionally to that, if we deploy, for example, our agent, our Prisma Cloud Defender on a Kubernetes cluster or on a different type of workload, it can also tell us what actually is going wrong. At the bottom, you see that we are actually experiencing code injection and SQL injection attacks on this workload. And on top, you see this one, unusual high volume data transfer activity. And this is also by ingesting the flow logs into Prisma Cloud, having more context. And we use the flow logs actually, and we enrich them with data about the IP address. Where is it coming from? Is the IP address used in a malicious campaign? We know all of that. And we also use the VPC flow logs to build a baseline with machine learning to tell you right now if there is a peak in data traffic coming to or going from your assets in cloud. So this is all the context that Prisma Cloud has. And now we see things that could go wrong, but also are actually going wrong. So I want to quickly do something with this. I go into the asset. Let me check. And in 2 seconds, I can now see that this asset is part of the front-end application of our national bank. That is quite valuable information. We know who the application owner is, and we know that the business criticality is high and it's a production environment. So this is really good for understanding. And now I am extremely worried and I want someone to fix it as soon as possible. So I click send to, and I select a specific template, and within a few seconds, I can warn Ricardo, the business owner of the application, that this is an issue that should be fixed immediately. In the slides, I also showed fix in cloud. So if we have specific misconfigurations in your cloud environment, Prisma Cloud can actually do auto remediation or guide you and how to extremely quickly fix the issue in your running cloud environment. So I could say execute command or just copy and paste it, and I have fixed this misconfiguration. But actually, this is seen as a temporary solution because nowadays everyone creates their infrastructure with infrastructure as code. So it can be a Kubernetes daemon set, YAML file, but also infrastructure as code like Terraform. And we also see that vulnerabilities are often defined in the code. For example, in a Docker file, in your Python requirements file, or a Helm file. And in this case, look at this vulnerability, and you see I have now the option to go for fix in code. And this is because Prisma Cloud was able to see this runtime asset and actually understands where it's coming from. So we can directly relate the runtime to the source. If I now press fix in code, Prisma Cloud will generate a pull request. And let me show it to you what it looks like. This is a pull request generated by Prisma Cloud. It suggests a fix to a newer version of this software actually. And now we are entering the developer workflow, and the developer does not need to go anywhere else than his or her own tools. Let me now switch to the runtime part, because we can not only do this, by the way, we can create pull requests. Let me briefly show it to you. We can create pull requests, but Prisma Cloud is also able to scan pull requests. So if we onboard a repository and a developer creates new infrastructure as code or a Docker file, they could easily create the pull request just within their own workflow, and Prisma Cloud is able to scan that workflow actually and scan the pull request and give feedback. So let's have a look at this one. Here we have a certain user that created a pull request, and we see Prisma Cloud has found errors and is actually suggesting fixes. So we scan for secrets like access keys, but also vulnerabilities and misconfigurations. Before I go to the runtime demo, there is one more step that I can show you, one more step that we can go more to the left, because we believe in prevention first. That's even better than prioritization of alerts. And how we do that actually is by integrating into the IDE of the developer, like IntelliJ or Visual Studio Code. And what you see right now is just a typical environment where a developer can create their code, their Python file, maybe a Helm file for Kubernetes, a daemon set, or in this case, an S3 bucket. But you need to make sure that you have no misconfigurations, because if you use this as a template and it gets deployed multiple times, you'll end up with a multitude of alerts. So this is what Prisma Cloud is able to do, integrate into this environment, and as soon as the developer is writing code, giving feedback on what is going wrong. In some cases, we can even fix it here. So I'll say apply fix. And we see Prisma Cloud actually fix the code. And now the developer can generate the pull request, and the pull request will be approved and going through to the runtime environment. Before I wrap up my demo, and I'll hand it over to Ravan in a few minutes, I will show you actually what we are able to do in runtime. So this is my Prisma Cloud tenant, and I'll show you two things. The first one is admission control. So Prisma Cloud can also act as an admission controller on your Kubernetes cluster. And the second one is runtime. And we can actually, with runtime, prevent zero-day attacks from happening. Let's look at admission control first. Let me switch to this one. So this is K9S, and I'm managing my Kubernetes cluster. I have an attacker demo, and I'm actually an attacker. I try to gain access, shell access to this container, but I'm running into this setting with the admission controller. It says block execution or attach to a pod. You see, I try to execute a shell on this pod, but it prevents me from happening. And that is because we have enabled this option. And of course, if I go to the events, I can show you what is happening, and Prisma Cloud will tell you why we cannot access this. If I disable it, I can go to phase 2 of my demo, because now I've actually got access to this container. And suppose I'm an attacker, I can start this zero-day attack simulation. And the thing is, with a zero-day attack, this is different than a known attack where we know a specific CVE. For a specific CVE, it's more easy to block actually, because you understand what the attacker will do and where the weakness is. So for example, if we have log4j, we can help you prioritize it, fix it, and prevent from happening. We can do that as well. But what I want to show you here is actually how we can prevent behavior that an attacker is doing and that was not known before. So actually it simulates a zero-day attack. Let me briefly go into Prisma Cloud again and look at the specific rule that we have here. So I go to defend and runtime, and you see I disabled this rule, but in that rule actually we can prevent a lot of things. So we detect and prevent Kubernetes attacks, we have advanced threat detection, but we also look at the processes, networking, and file system. And there's obviously, we understand crypto miners, reverse shell attacks, and we block them. But additionally, we use the learned models. And in this case, Prisma Cloud understood the default behavior of my container. the zero-day attack simulation was not in the default behavior. And you see, we just say all other processes should be prevented. We could also block, and that last one actually stops the container if we see malicious behavior. Right now, I'll put it on prevent, and you see the rule is disabled. So if I execute this zero-day attack, I can see that I'm able to open the password file, execute the EMI, and I'm obviously, you see I'm root, and I can download and execute malware. What happens if I enable this? And Prisma Cloud looks actually at the behavior inside and outside of the model. If I execute this zero-day attack again, Prisma Cloud was now able to block it. And instead of blocking these processes specifically, we could also say stop the container and thereby also disconnect the attacker. There's much more within Prisma Cloud, but for now I'll stop sharing and I'll hand it over to you, Ravan.
Thank you, Stephen. So I need to share my screen. Okay, can you see my screen?
We do.
Yeah, we can.
Okay, excellent. Okay, so I'll take the story a bit further than Stephen did a little while ago, and showing you how this concept of security, zero-day attacks, and things and how that could materialize into an observability solution, so that actually the dev teams and things that actually are responsible for these applications get a better understanding of actually what's happening with the applications in the production environment. So with this, I'll first start off with showing StackState as observability solution. We'll go a little bit into troubleshooting, how we utilize troubleshooting, and finally, we'll tie back into Prisma Cloud to see how we utilize information from Prisma Cloud to actually diagnose a problem with a container. So as Mark and Stephen mentioned, everything is about context, and point-to-point solutions often miss that context because you're doing tons and tons of context switching. So with StackState, we try to simplify the Kubernetes troubleshooting world and observability world by giving you lots of context in the system. To start off with, we start off with the normal things that people know about Kubernetes, their workload, storage configuration, etc. And these are the type of entities that developers would work with on a daily basis. We'll drill down into services just as a start. For any Kubernetes resource, StackState actually allows you to look at the resources, the health of the resources. Are they orange for maybe it's a warning, red it's actually deviating, critical, and green is absolutely fine. So these are the different types of visual clues that StackState will give through to you to understand your resources. Resources can be anything from services again to namespace, clusters, nodes, etc. An important aspect with StackState is that it allows you the capability of actually looking at multiple clusters. So you can observe multiple clusters in your system, and you can actually look at how your application is deployed on these different clusters, etc. We also look at it from a namespace perspective, so we can filter down on namespaces to help you create views that are more relevant to your teams. Another important aspect when you're doing observability and troubleshooting, when things go wrong, it does not go wrong now. Basically, something had happened in the system previously, and we only seen the effects of it right now. So in StackState, we have the concept of time travel, and with time travel, we can go back anywhere in time to actually look at how the system was at that particular moment in time. If you just scroll down here, so now if I go back to 2 hours ago, 3 hours ago, whatever the case is, I can understand how my system was at that moment in time and what were the components that were in error. Sometimes understanding the individual part of things is handy, but you also need to know how things are put together. And this is where the topology view comes into play. The topology view within StackState understands your application and basically understands which cluster it's deployed to and how it is deployed on those clusters. So in this example, I've got my application running on 3 clusters. On 2 of those clusters, I've got the same application, but my services are spread across 2 clusters, And I can also understand how the communication is happening between these two clusters. The StackState agent understands communication and can trace how a call flows all the way from your service and which pod it is on, container, what's the process that's in there, which other process does it call, and where does it live in another container, in another pod, in another service. So this is your ability to actually look at your system and understand, compare environments, and understand how things are behaving on your system. So let's just filter this down to one clusters. Okay. So when we look at it from a single perspective, besides understanding the communication, we also have the ability to understand communication through service meshes, for instance. So if you had a service mesh, StackState would have picked it up in here like Istio and shown you the proxies in between. For each component in the system, StackState assigns a role to it, whether it's a service or a pod or a cluster, whatever the case is, and pulls back important information about that component. So StackState, based on best practices, we understand exactly what type of metrics, etc., are applicable to this particular component, and StackState automatically gathers this information and displays it for you without any problems. The service map is very interactive, so we can look at it, drill down, explore, etc., to understand how a component is put together. So we understand, for instance, like a pod, it's running on a certain node that's using a certain volume that could have a different type of config map, etc. So understanding a system from a topological perspective really helps to create context and how items are communicating and things like that. If I go back to my overview and if I go to one level deeper into a component, for instance, the next thing that StackState brings to you is tries to bring back information from all the different metrics, logs, events, etc., and portrays it to you on a service and gives you the highlight of this information. So information like more static configuration type of information is things like when last was it deployed, what was the configuration used to actually deploy this application on the cluster. Does this resource have any related resources, like for instance, a service is backed by a pod, for instance, so we can understand the natural hierarchy of Kubernetes and helps a person navigate that hierarchy with ease. Other important aspects is metrics that belong to a certain resource. Within StackState, per resource, we've got the best practice metrics already configured out of the box. And for instance, for a service, you'll look at things like mostly your golden signals, your latency, your error rates, your saturation, etc. So all of this information is available to you, for you to look at, and for you to look at it either as a normal traditional dashboard that's automatically generated by StackState, or understanding these things. The next important aspect is about changes in a system. Changes in a system causes errors most of the time, and understanding all of the different types of changes that occurred in the system, your deployments that occurred in your system, what alerts were given out in the system, etc. These can all be done using our timeline, our events timeline correlation. So we can understand by looking over time how all the different changes and alerts affect each other. So you can start to spot trends, etc. on these items. Finally, the way that we utilize all of these things to actually solve problems is through the use of monitors. So with monitors, StackState ships with about 28, 30 best practice monitors, and it starts to monitor your Kubernetes cluster. A monitor has a definition. What is this monitor all about? We have a timeline for it, once again, to see how this monitor behaved over time, the metrics that's getting involved. And another important aspect is about the blast radius. Because we understand the topology and how items are all linked to one another, Kubernetes can be a very noisy system. So which means alerts and failures in other parts of the system could be red herrings. StackState analyzes this part and basically helps you to try to understand which is the most likely path that you should start to understand a problem. And this, for instance, if I click right to the bottom, I can see that my catalog pod is actually affecting my the rest of my system. Another important aspect is about, besides a signal and alerting on what's going wrong, StackState also helps you with remediation guides to help you troubleshoot the problem. So for each monitor, we have different guides that are going to help you navigate the system to try to find the problem. Let's drill down one level to the catalog to look at this pod and see what's happening with it. So now, for instance, I can see additional information about my pod. For instance, I get to see the logs now. StackState categorizes the logs. It tells you which items have errors, warnings, etc. We can drill down into the log and do searches, etc., to understand what this container, what these pod logs are all about. The next aspect we'd also look at is other types of important things, important metrics for the pod itself. So StackState will look at your CPU, your memory usage, etc., to help you understand this problem. So if we go back into the guide again, and I'm just going to zoom in a bit so we can let's go into this area. So we'll zoom in on time to try to understand and diagnose a problem, for instance, why we have an OOM killed. In the guide, basically, we have several important parts in the metrics that may be of interest to us. So StackState allows you the capability to drop markers at each one of these points, for instance, so that it's going to help in your diagnosis, because as we go along our diagnosis process, we're going to see these important markers come back in multiple timelines and multiple metrics. Other important aspects that we'd look at when we're looking at the guide is going to tell me, how do I go about actually troubleshooting this? So I could have this concept of new deployments, elevated traffic, etc. And by clicking on any one of these items, I can drill down into that specific part of the system where the system is going to help me to try to understand certain things. So certain things that I can see up here, it's not interesting. So certain things that have interest up here, I have my guide on the side, so I'm not losing context again. I can follow the information that's in my guide, and it'll inform me about things like looking for a sawtooth pattern for a memory leak. And I can see that sawtooth pattern up here because we can see it going up, hitting a limit, and then dropping down again. So this is pretty interesting for me. I can look at other metrics that are important to me, and I can also start to pin it onto the right-hand side. So now I have a little troubleshooting scratch pad that's available to me to help me come along with my journey to diagnose the problem. Other important things when you're trying to spot these things, talk about patterns, but they also talk about look for events. All right, so when you look at events again, we drill back into our events correlation overview, and we can see things like I had my OMM kills at certain moment in time. I think I should expand my timeline. I should go live. Sorry, I'm just going to increase my timeline. Okay. So we got the timeline up here. Okay, so we're back on this one. So okay, so yeah, so for instance, we see where our out of memory alerts were. Other important things we look for is type of changes that occurred in the system along that time. So changes, we can look at our deployments, understand the deployments. We've got a deployment that took place at 1101. If we look at our 1101 deployment, we get to see metadata about the service. Like for instance, it was a version update, went to 3.6. Other important things we can see is links to source code. So for instance, if we click on the link for the source code, we end up actually logging into the source code system, and then we can understand why something is wrong, insufficient code, etc. that's been added up here. So the idea is we went from looking at events, we went looking at changes, and from the changes, you try to drill down into this, to the source of the problem. Now, using this correlation aspect, we could also use it to diagnose other types of problems that occur outside the normal realms of your runtime. So like for instance, if we're looking at Prisma Cloud, Stephen showed you how Prisma Cloud can prevent intrusions onto a system. So for instance, I can see in my Kubernetes space that I have tons of restarts that occur. So if I look at my restarts, zoom in on my restarts, I can understand things like what were the alerts that were occurring on this restart? Why was this occurring? So by incorporating Prisma Cloud, we can ingest events, rules that fired in Prisma Cloud, and project it onto the right service so that the developer actually knows that there's some external force being applied to his services, his containers, that is affecting his performance. So in this particular case, we can see that Prisma Cloud has detected an intrusion, and basically it had a denied rule, and basically from here we can see exactly what went wrong. As a user of the system, with a simple click of the button to keep context and to keep this concept of context going, we go to the source of truth, and from the source of truth, for instance, we can start to analyze things like, okay, how was this attack taking place? What was it all about, etc. So you can have a nice handoff from your observability system, understand that there's some external platforms protecting your environment, and you can see how that affects you on a day-to-day basis. Other important aspects is that Prisma Cloud also allows you the concept of compliance. So by bringing in that compliance information, we can also see in one go which compliance violations is my application in. So I could drill down into my compliance report, basically, my monitor that fired. I can understand all of the different compliance issues that are currently occurring in the system. And once again, to maintain context, with a simple click of the button, go across to the source of truth and understand what's happening at a more in-depth level inside Prisma Cloud so that you can understand these items a bit further. So with that, I'd like to stop this demo. There's much more I could show you, but this is the most interesting part about how important it is to move away from point solutions, get platforms that actually work for certain disciplines, and how important it is to share information across those platforms so that it can work seamlessly for different disciplines, giving you end-to-end visibility. Okay. Stop. Okay, so I think I'll hand over to Genevieve.
Sure, thank you. Thank you, Ravon and Stephen and Mark for the demo and also for the presentation. So, okay, so we are into our Q&A section. So we actually do have a couple of questions from our audience. First and foremost, for Prisma Cloud, what agent do we need to install to cluster? And do we need to install the agent to each container, and how?
Okay, that's a great question. Actually, the agent in our case is called the Prisma Cloud Defender, and it's actually a daemon set on a Kubernetes cluster. So it's very easy to deploy. There's no need to attach it to each container. You can just deploy it as a daemon set. And for example, if you're using GitOps to maintain your cluster, you can just onboard it by using that workflow. Additionally, we also have information on the performance, because the other question that we regularly get is how much resources does it take? It's actually quite low. So it doesn't use a lot of memory and CPU. It's really low, but it brings a lot of value in terms of protection and detection. So I hope that answers the question. Otherwise, let me know.
Thank you, Stephen. All right. Another question that we received from the audience is, do I need to instrument my applications to get the service map connections?
I can answer that question. Also, StackState uses the daemon set, and there we use eBPF code to basically instrument your applications from a kernel level. And there we basically see all traffic, if it's encrypted or not, and see how everything is connected to get the service map directly after installing the agent. So within a minute, you get the value there.
Thank you, Mark. Another question that we received is, can I create my own guides?
Yeah, sure, I can take that. Yeah, like the mediation guides that I was showing you, they're completely extensible and they can be used and customized for your needs.
Great. For Prisma Cloud, do we need to use the whole code to cloud platform, or can we focus on runtime?
Yes, it's definitely possible to focus. Actually, we have customers using all of our capabilities from code to cloud, But we also have a lot of customers that use either a specific use case, only runtime, or only code security. So all, everything is possible within between that.
Great. And for StackState, can I add my own metrics?
Yes, that is possible. We support OpenTelemetry and OpenMetrics for that, and then you can send over metrics to StackState. You can also bind them to the different components.
All right, so we also have another question is for Mark, it's for you. When you see alerts in red, obviously it would trigger a ticket or the severity. Do you enable the tech group for breach or incident, or you refer to the system information breach? And I'm hoping I read that question right. And if you want me to read it again, I can.
1 second, I also try to read it and to enable tech group for breach.
I think I understand the question. It's twofold. I think one is from the StackState half and the other is from Prisma Cloud. From the StackState perspective, yes, indeed, things that you see in red or also in yellow and things that notifications can be triggered. I didn't show that in a demo, but we have a complete notification system that basically fires based on a whole set of trigger rules so that you can get your information sent to the right team through the right channel. And the second half,
including the right context in the alert directly to get you at the right place.
It's exactly the same for Prisma Cloud. We also have an alert routing system. So depending on where the application is or who the owner is, we can route it to the right people and the right department.
All right, and we also have another question is which license is required to enable Prisma Cloud security? And the same question to StackState, whether Prisma has integration with StackState.
Okay, yeah, I can briefly explain the Prisma Cloud part. We use with a credit system. So it's basically you pay for what you use and you need to buy credits, and within the system it's up to the customer if they want to use the credits for code to cloud in full aspect, only for code scanning, only CI/CD scanning, or only runtime. So it's really flexible if you have the credits to use the capabilities.
For StackState, I can answer that question. We have a very simple license model based on the amount of hosts you have, and then you get the full functionality basically. And then there's also a question whether Prisma has an integration with StackState. Yeah, as we showed you today, we have an alpha integration indeed, which will be extended in the upcoming period.
Oh, great, thank you. All right, we have time for probably 1 or 2 more questions. For StackState, can I edit the Kubernetes configuration?
You take it, Rob?
Oh, I can take that, yeah. Yeah, so with StackState, you cannot edit the configuration because StackState follows GitOps principles as well, so that if you need to make changes, you should follow your normal GitOps process to push changes into production. That's why StackState is the perfect solution for platform teams to enable their developers to have a read-only view of their production clusters that backed by RBAC again, and help them to diagnose problems and troubleshoot problems without having the worry about changing items outside of their normal GitOps type of process.
Great. And then for the last question that we have is, we have so many vulnerabilities. Can Prisma Cloud help us prioritize?
Regarding vulnerabilities, we have a specialized vulnerabilities dashboard. And for each vulnerability, as showed in the slides, we know where the impact is. But we also have a lot of context and risk factors for each vulnerability, like is there an exploit available in the wild, which is really valuable. And we also show a funnel of all vulnerabilities, only those that have a fix or have an exploit. So yes, there is some great tooling within Prisma Cloud to help.
Oh, all right. So I know we're coming close to the top of the end of the hour. So just want to say thank you to everyone for joining us today. This presentation has been recorded and a copy of the recording will be sent out to you all. And Mark, if you can just go forward, like just one. So we do have additional resources for you. I also put, some links in the chat, for you to actually get access to it quicker. But we have the Forrester Wave Cloud, complements Prisma Cloud. that you can download. There's also the illustrated guide to troubleshooting Kubernetes applications. And then if you're interested in a free trial of StackState, you can either go here in order to get access to a free trial. And we also have access to a playground that if you also just want to try it out in our own environment, I'll put a link into the chat. But that concludes our presentation, and hope you all have a great rest of your day. Thank you all.
Thank you.
Yes, bye-bye.
Bye-bye.
Thank you. Bye.